Okay, moving on with getting everything in factored form. We've factored by dividing out a monomial. We factored by grouping. We factored quadratics. We factored quadratics with coefficients on the second degree. Now we're going to look at our special products and how we can factor our special products. And if you remember, one of our special products was called a difference of squares. A difference of squares. And that always deals with a binomial. Okay, it can't be anything else besides binomial. So our polynomial with two terms. So now we want to look for binomials that have a difference. So in this case, a minus sign, right? Difference means subtraction. A minus sign. A difference of squares. Well, I got to see if I am able to take the square root of each term and come out with a whole number or a variable out of that. And so if we take a look here, let's expand out our binomial just so we can describe our special product. We go through the FOIL, we get a squared minus ab plus ab minus b squared, right? A times a times negative b times a, and b times negative b. And if you take a look, what happens when we use that FOIL is that our middle two terms here, they cancel each other, and we're left with a squared minus b squared, hence the difference of squares. So we're going to take that a squared minus b squared, and we're going to factor it back out into that product of two binomials. So let's take a look. It'll make much more sense going through examples here. So there's just two things we want to look for. Look to see if it's a difference, and look to see if you have squares for both terms. So I take a look at my first one. It's a difference. I'm good. Well, can I take the square root of m squared and the square root of 64? You bet I can. So I can break this into a product of two binomials. We know it's going to be a plus and a minus. Well, the square root of m squared is m. So m is my first term. The square root of m squared is m. And then the square root of 64 is 8. So 8 and 8. And I'm done. So a difference of squares factors into my product of the two binomials, one with addition, one with subtraction. That's going to confuse you there, having those signs. Okay. So m plus 8 times m minus 8. Let's look at the next one. Difference, we're good. Can I take the square root of each of these two? Yes, I can. So I can break this into a product of two binomials. The square root of 16 is 4. The square root of y squared is y. And the square root of 81 is 9. Square root of z squared is z. And I have a plus and a minus. And there you go. And you're done. So if you can find that special product, that difference of squares, you just factor right into that product of the two binomials. One with the plus, one with the minus. Let's keep looking here. Number 3. Well, I have a difference. That's good. I don't have squares though, do I? Huh. So that means it's done. I can't get it in factored form. Well, remember, when I get something in factored form, I can follow all my rules I've done so far. So can I factor something out of there? Well, if you take a look, there's a 3 goes into both terms, and I could pull out a b as well. So I can pull out a 3b out of here. Divide each term by 3b, which leaves me with b squared minus 9. Okay, so now it's factored. Well, what do you notice? I got a binomial inside my parentheses, so I should probably check and see if it's a difference of squares. Got the minus sign, there's the difference. Can I take the square root of each one? You bet I can. So let me bring my 3b down here. And now I can factor this into a product of two binomials, one with a plus, one with a minus. The square root of b squared is b. The square root of 9 is 3. And I'm done. I've factored everything out. It's in factored form right there. Okay? So you got to look for all those things now. The first thing should be, can I factor something out? So if you can factor something out, you should do that. In this case, we factored out that 3b. And then I take back a look, and I have a difference of squares. So you got to factor that as well. Taking a look at the next one. Look for that difference. Oh, it's a plus sign. It doesn't matter that these are both squares, okay, because I have to have a difference of squares. I cannot break that up. So that's already in factored form. So we would just say this is prime. I can't factor anything out of there. Okay, can't factor anything out of there. I can't write it into a product of two binomials either. It's just done. That's prime. Okay? So don't be tricked by that plus sign. Don't be tricked. Okay, keep going. Got a difference. Good. Squares. I can take the square root of that, right? Square root of y to the fourth is y to the second. Because y to the second times y to the second is y to the fourth. Square root of 625. Might need to take that on a calculator if you're not sure. But it is a perfect square. So I got plus minus. We said that's y squared. Right, the square root of y to the fourth. And the square root of 625 is actually 25. There we go. Good. Wait, hold up. Somebody see something there? I think I see something. What do you notice in that second binomial? It looks like you have a difference of squares. So I can break that up as well. So I'm going to bring down my y squared plus 25. I can't do anything with that, right? Because there's no difference there, even though they're squares. But I can break this next one up into a product of two binomials, right? One with a plus, one with a minus. It's my special product. Square root of y squared is y. Square root of 25 is 5. Now we're done. That is in factored form. That's in factored form. Okay, so there's a lot of rules of this. But you got to keep factoring if you can. That's the important part. So I have a binomial in number 6 here. Let's check and see. I got a difference. Good. Do I have squares? I might have to check it on a calculator again. In this case, 256 is a perfect square. So I can write this into a product of two binomials. And the square root of 256 is 16. Plus, minus. And the square root of n to the fourth is n squared. Okay, once again, I better look inside both these. Can't do anything with that first binomial, right? Because there's a plus sign. The second one, I have a difference. Do I have squares? Yeah, I can take the square root of that. I can take the square root of that. I better go ahead and break that up. Bring my first one down, because I cannot factor that. And my second binomial factors into 4, right? Square root of 16. And the square root of n squared is n. And now we're in factored form. Factored form. Okay, so you just got to look through all your different rules. Same thing with 7. I'm looking, I got a difference. Good. Do I have squares? Well, the 9 I can square root, the 36 I can, but I can't square root an odd exponent. Same thing with here. Can't square root that odd exponent. So we always got to look, can I factor something? That's what I should have looked for first. Right? Instead of looking for that difference of squares, let's see if we can actually factor something out of there. If you notice, I can divide a 9 out of there, and I can also pull out an x, which leaves me with x to the fourth minus 4, just 4, right? Because I pulled that x out. Now start looking for your other things. All right, I got my difference. Do I have squares? I can take the square root of that. I can take the square root of that. Good, we can break it up. So bring my 9x down, and we're going to break it into a product of two binomials, one of the plus, one of the minus, and we get x squared, and the square root of 4 is 2. There you go, and I should be done. If I look at my second binomial here, I have a difference. I can square root the first. I can't square root the second, though. So that does not break up. So I'm done right here. I'm done. Okay, lastly. Uh-oh, I got 4 terms, don't I? You should immediately jump to grouping when you got 4 terms. So I better group these. I'm going to go ahead and group the first 2. Before I group the second 2, I want to change this to adding the opposite, right? Adding the opposite there. It's much easier to work that plus sign. Okay. Out of this first one, I can pull out a 6x squared, it looks like. So pull out a 6x squared. And I'm left with x plus 5. Okay, so on the next one, I want to try to pull out something that will give me an x plus 5, right? So hopefully I can pull out a negative 24, so I'm left with just an x there. Let's try it. Let's see if I can pull out a negative 24. Left with x, negative 120 divided by negative 24 gives me a positive 5. How does that look? Good. That's good. I got binomials that match up. That's what we're looking for. So now we can write this as a product of two binomials. If you remember, one of them is going to be x plus 5, and the other one's going to be 6x squared minus 24. So I got 6x squared minus 24 and x plus 5. Remember, don't get done until you can tell that everything is factored. If I look at this first binomial, I can still pull something out of there, can't I? I can pull a 6 out. So I'm going to divide each term by 6. Left with x squared minus 4, x plus 5. Okay. Always look back through. Am I done? Let's see. The x plus 5, can't do anything with that. Can I factor anything out of this x squared minus 4? You bet it's a difference of squares. Okay, you got to always look for that. So I still got my 6 out front. This is going to break up into a product of two binomials. And I still have my x plus 5 at the end. And so I got a plus and a minus, right? Square root of x squared is x. The square root of 4 is 2. So that is my final answer. And it doesn't matter what order this is. I mean, I could flip around my x plus 2 and my x minus 2 and my x plus 5. Doesn't matter what order those are in. It's all multiplication, right? But you just got to keep factoring. Keep factoring if you can. Let's do an equation with this. It gives me this equation, y equals x squared minus 4 over 25. It's asking what x is when y equals 0. So let's plug in 0 for y. And that's our goal, right? When we have a polynomial to the second degree, we always want it to equal to 0. So we're good so far. Well, we always want to factor when we're to the second degree. So can I factor this? Well, I have a binomial. It's a difference. Is it a difference of squares? I can square root that. Can I square root that? Can I take the square root of 4 over 25? If you remember our square root rules, I can break that square root and take the square root of 4 and the square root of 25, which gives me 2 over 5. So I can square root that. That's actually a difference of squares. So I can break this up into a product of two binomials. Plus and a minus. So I got x, and the square root of 4 over 25 is 2/5. 2/5. And to solve, remember we set each of these equal to 0. Set that equal to 0, that equal to 0, and solve them both. So x is going to be, I need this to be negative 2/5. So negative 2/5. And this needs to be 2/5 to make that 0. So x equals negative 2/5 and 2/5. Okay, so just make sure if you have a fraction, you can square with the fraction if both the numerator and denominator are perfect squares. Okay, most important thing, just keep factoring as long as you can factor. Whether you're pulling something out, whether you're factoring a quadratic, whether you're factoring by grouping, or you find difference of squares. Thank you.